Op-amp circuits transconductance. You remember, if you see a transconductance, this means that you're going to transport a certain amount of signals from one place to another. Right? So if you're going to transmit a signal from a very long cables, right, a very long distance, you have to ensure that instead of transporting a voltage, you're going to transfer a current, right? Because current in series will not change at all, right? It will not change at all. So in this case, how do you want to connect a system? Why do you want to connect a system like this? So you are transferring a signal, okay, a current signal, through a wire. Okay, this is through a wire, meaning you're going to transfer the amount of current from the side in. Okay, so you're going to transfer it through a line of wire. Right. So at this point of time, some maybe one household gonna use this R load over here. So he gonna tap on some of the, like maybe refrigerator or rice cooker or washing machine. So some of the R load will actually takes in, and then you actually so-called give a change in your voltage, right? However, in this time round, you have to ensure that your current you are transmitting in terms of current, right? Because as I said earlier, current in series is it will not change at all. So the current itself will enter into this R loop, so it will be V equals to IR in this case. So the amount of voltage will be used whatever voltage you want. Okay, so the voltage will be used in this household. So when it yeah, if you have another household, okay, you have another system like this, where you have another system like this, and then this will goes into your input. Okay, so hold on. If you have another household like this, you're gonna input the current, and then you're gonna go in, and then same thing. So you're transmitting current throughout the whole thing instead of voltage. So in this case, it's much smoother lah. However, one thing is that I may be wrong. So, but anyway, the concept is there lah. Okay, the concept is there is that you have to you put in a voltage. Okay, this is the power source, right? A V in. However, when you're you're transmitting the current flow throughout. Alright, so so if your voltage it comes in into here, and you have a certain R load. Okay, this R load is I don't know yet. Alright, so you go in, and then you interact with this 250 ohm. Right. So if you remember, V is equals to IR. Right. So if the voltage itself, if you put in a 1 volt, okay, if you put in a 1 volt, so V over R is equals to I. If you put in a 1 volt over here, and then a resistance 250 ohm, what do you have? You have a 1 divided by 250, you have a 4 microampere, right? Which is exactly the same as this range over here. So without any load, you will not have your ampere will be 4. Okay, your current will be always 4. Where your current will be always 4. However, if you have a new load, okay, if you have another load over here, if your household has a like refrigerator turned on or whatever, so you will have a much lesser, maybe if this is 750 ohm now, right? So you have a 70 plus 250, you have 1000 ohm, right? So you have a much lesser current in this case. So you know that there is someone using the current, so you can actually do something with it lah, you know. This analogy, if you want to extend to the household one, as which I draw along the whole wire line, okay, the wire line thing, I don't know what the fuck lah, okay, I don't know how to explain already. But nonetheless, you're going to connect a long wire through with a voltage of 1 to 5 volt signal range. And then maybe at a certain household, we have some voltage that connects to this circuit. right? Right. So you have so this will connect to this point, and then individually you can calculate for what are the currents used. So this is where every household electricity, how they can actually measure your amount of electricity used. So this is how this is being transferred lah. So you transfer a voltage. So this voltage can be tapped into the system first, and then if there is a change in current, okay, then you feedback. Maybe there's some feedback systems lah. Where's the feedback system? Yeah, I don't know how to draw the feedback system lah. But nonetheless, if maybe you put an emitter over here, and then you have a referencing emitter or whatever lah. Okay, I don't know what the fuck I'm doing. So you will know is there any change in current. So you will know that okay, someone is using the amount of current. So this is the thing I'm going to talk about, and I may be wrong, but certainly it does explains how to connect a transconductance. So in this case you can just straight away remember this one. Okay, for a long wire, long piece of wire, you can straight away use this one. Right. In a more defined way of saying is that current signals are unaffected by impedance of circuit, provided that power supply can provide appropriate voltage. Right. So amount of voltages is being applied over here. Right. Is some range lah. Okay. So thus currents are more reliable for conveying signals in situations where resistance are unknown because of long wiring. Because long wiring, if you remember, resistance is based on R equals to rho over L, I think. This is some constant. I forget lah. I think A also. So typically the length itself will affect your resistance. Right? The longer your length, you will affect your resistance. I forget how the hold on, damn it. So this is the length. The longer the length, the longer your resistance. Okay, so this is the formula. The longer the length, the longer your resistance. So there will be a certain unknown of resistance, and there will be a unknown of R load also. So these are the things that is a little unknown. So to be safe, you will use like current signals to convey. So the very long wiring or unknown resistance will use current signals instead of voltage signals. Right. So yeah. So I'll see you in the next video to talk about calculating noise. Right. So yeah.